how to manage large mono-repos in Gerrit. And I'm from GerritForge, and GerritForge is a company that the first and unique mission is to provide enterprise support for Gerrit code review. And we are moving to the US, and we have now GerritForge Inc. based in California, and all the business will now be based in the US. But let's have a look what actually big means for different people. So first of all, I wanted to clarify one thing, is that a lot of people thinks that actually large mono-repos, they are going to be sorted out by just using git-Ifs, because they say, okay, large mono-repo, it means large file, so git-Ifs, L stays for large. So they actually think that by using git-Ifs, they will actually solve all the problems related to large mono-repos. So there are honestly some benefits in using LFS. So the repo becomes smaller because you got less blobs in the repo. The bandwidth utilization becomes less of an issue, and of course you use a lot less disk space locally. There is also the variant, for instance, from Microsoft with GVFS, and there are all the flavors about the large file system implementation. There are some dark sides though, so LFS is not coming for free. I don't know if you have implemented LFS in your organization, but you know that you need to rewrite history, one thing, and then you have to have a static definition what big means to you. So all of a sudden, you will start realizing that whenever you put some limit, maybe if the file is bigger than 1 gigabyte, then put into LFS, you will notice that people will start splitting into smaller files, and you have the same problem again. But actually, the LFS does not solve the problem so large mono-repos in Gerrit. Let's have a look why. What are the different type of objects you've got in the Git data model? So this is roughly how the Git data model looks like. So you've got different commits, they're pointing to trees, they are pointing to different blobs that contains the actual files, and each one of them has a specific SHA-1. And then you've got the refs. The refs are basically just labels, they are pointing to SHA-1s. So you have the ref here, so they're just all the labels you can have, and you got the objects, and the objects could be of different types. Yeah. So when I mean large, I'm not talking about just one dimension, that is the disk space, but there are actually other 2 dimensions. So what happens if you have a very large number of objects? Maybe each one of them is small, so each one of them will not actually be resolved in terms of disk utilization by LFS, because maybe they are quite small. Maybe imagine that each object is something like, let's say, 1 megabyte or 5 megabytes, but you have many objects. Maybe 10 millions, 20 millions, 100 millions, and so on. Or what if, let's say, you don't have so many objects, but you have a lot of refs? And a lot of refs seems kind of unnatural to be an issue, right? Because refs are just pointers. So how can I have a lot of pointers? How can that create problems to Gerrit code review? So we said that if you want to implement git-Ifs, you're going to address only the disk space issue. But what about the other 2 issues? First of all, to understand where are you in these 3-dimensional categorization of large mono-repo, I do suggest to use a tool that is called git-sizer. This one is being developed by GitHub. It's freely available on GitHub as well. And this is just a sample execution of a git-sizer on a large mono-repo, and in this case is Chromium. And you see the level of concern of the dimension on the right side. When it got some stars, it means is problematic. When it got the exclamation mark, the banks there, it means is very, very, very problematic. And in this case, you see that it's not just the size of the repo that is problematic for Chromium, but also the overall number of objects. Yeah, how many of them are there, and how much size they occupy overall. And let's go and let's deep dive a little bit into some more Gerrit-specific issues. They are actually kind of created by Gerrit itself, and they are very peculiar to Gerrit. You won't find them in other Git repository management systems. So let's talk about, for instance, the number of refs. So you know better than me that whenever you create a change, actually Gerrit creates many refs. If you create just one single change with one single patch set, actually Gerrit already creates 2 different refs. So one that is for the change number in the patch set one, that is your first patch set. And because this one has already created some initial metadata for Gerrit, you have one ref that is ending with /meta, that is the metadata. And whenever you upload a new patch set, you create a new ref into the changes. How this is a problem? Let's talk about, for instance, a medium-sized repo. So this is not a very large one, but just a medium with 100,000 changes. I will demonstrate to you that is not a very big one, 100,000 changes. And imagine just 10 patch set per change. And that is very optimistic because I clearly recall some of the patch sets in Gerrit code review that we went over the number 99. So we had 100 patch sets or even more. So if you think about 100,000 changes and 10 patch sets, you need to think about that these will generate 100,000 multiplied by 11 because it got 11 patch set plus the meta ref, and the result is 1.1 million refs. Okay, so this looks a big number indeed. However, why is this a problem? Let's say you think that these are big numbers. Even if you reach these numbers, things are not going to go better. They're going to get worse over time. Because in Gerrit, whenever you merge a change, do you remove the old change? No. And even when people upload changes, but those changes, they never get merged, they will be abandoned, but they will still exist in the history. So they will still exist in the refs. So that means that when a repo gets in such a bad state, it cannot go better. It can always get worse because as the project continues to increase and continues to have changes, the number of refs always goes up, never goes down. Okay, let's give you an example on how you can get to those numbers. So when you have a mono-repo, you typically have a lot of developers working on the same repository. So if you think about a medium-sized team, 500 developers is not a very large team. So if you think about the companies you're working with, they got definitely more than 500 developers. And it could be, let's say, a medium-sized project. But imagine that all these projects, instead of using different repos, they use just a single repo. And imagine that developers, they create just one change per day. And actually, do you know that people using Gerrit, they tend to create many changes and chaining them. So that is really optimistic. If you think about 1 year, so you get 500 developers, 250 working days, you will get every year 127,000 changes. And what looks like if you go 5 years of history, you'll get up to 7 million refs. And I saw some numbers that were shared by the Qualcomm team. Yeah, they're definitely, let's say, close to some similar numbers as well. And just to give you some examples, so Chromium, so I never managed to do a full mirror clone. I had been running the mirror clone for about 3 weeks and then I gave up because it's so big that you cannot even clone it completely. But I managed to download 500,000 changes, 2.5 million refs, 42 million objects, and over 60 gigabytes of compressed disk space, because when you uncompress the data, of course, we'll get over 1 terabyte. So it's definitely a large repo. Okay, so what is the problem then with so many refs? So let's talk about refs first. So the storage is definitely an issue. So Git itself never wanted to include a proper database for the refs. And if you think about a series of labels, they are pointing to SHA-1s. Those are the perfect element that you would store in a database table, right? And if you have a database table that is very well indexed on a specific column, having, let's say, 5 million, 10 million rows is not a problem. However, in Git, you can have two storages. So the first one is loose refs. It means every single ref is a file on the file system. And you won't imagine how slow this is on NFS. I believe that Martin mentioned yesterday, and he was shocked how slow it was on NFS. I wasn't actually shocked because we saw that problem many, many years ago. So NFS is really good, let's say, in the loading data and giving you the impression that it's local. When you've got a smaller number of files, they are quite beefy. But if you have a very large number of files and they are all very small, then NFS needs to list the files they are in a directory. So if you want to guess how long does it take to list a directory with, let's say, 10,000 files, you will be shocked on NFS how many seconds, if not minutes, can take. I'm going to show you and share some numbers with you. But then, of course, the Git project realized the problem, and they introduced the packet refs format, where you got a single file with everything in it. Then, of course, is not going to scale anymore, because as the number of refs gets bigger, the cost of adding just one ref is going to be unbearable. So what Git is doing is basically keeping the packed refs, and the new refs they are added as loose refs. But then longer term, it means that you need to scan packed refs and loose refs at the same time, and you need to keep on garbage collecting and repacking refs over and over and over again. On NFS is a killer. And again, I'm going to show and share some numbers with you. So because the problem of understanding what are the refs and where the SHA-1s are located and where are the pack files they should be targeted with, so bitmaps were introduced a few years ago. But when you got a huge number of refs, the bitmaps, they get so big, they are unusable anymore. I recall that Matthias and Sasha from SAP, they were sharing that by disabling bitmaps, actually they got a performance improvement in replication. That seems really, really absurd, because bitmaps, they were thought about to make things faster, but when you got too many reps, actually they make things a lot slower. So those are some numbers, and those are really shocking. I'm going to show you why. Those numbers have been collected by Matthias Son from SAP. And you will see how long does it take to do a lookup of a single ref or a lookup of the refs by prefix. And those two APIs have been chosen because the first one is used whenever you need to access a single change, for instance, and the second is used whenever you do, for instance, a clone using Git protocol v2. And then you want to say, I want only the refs with this prefix. So you avoid all the big ref advertisement of all the refs from the server. And these statistics are public. So this is the link with the URL. And I want you to notice one thing. So the Chromium repo on NFS, it takes 2.1 second, and this is 2.1 second, for just doing a lookup of a single ref. And that is shocking, because you know how many times Gerrit does lookup of a single ref? Many, many, many times. Whenever you open a change screen, whenever you do any operation, you look up refs. And if you do a get refs by prefix, is even worse. Let's go now to a second problem. So what if you have then also a large number of objects? Or if you have instead a large number of objects? So there are issues there as well. So first of all, again, similarly to refs, you can have two types of objects. One is called loose objects. It means every single object is a separate file on the file system. And in that case, you've got tens of millions of objects, got tens of millions of files on the file system. And in this case, not just NFS, even your local file system will struggle to have tens of millions of files in the file system. Your file system is limited anyway, because you're going to occupy all the inodes, and you will be running out of this space even if you have enough disk space, just because you don't have enough inodes. Then, of course, you can start packing into pack files using repack, using GC, and so on. And the ideal number of pack files that you want to have in your repo is one. Yeah. So whenever you want to do the best GC ever, you want to have just one pack file with everything on it. So JGit is quite clever to do a lot of optimization on packed refs on NFS, not to be too slow. So I believe Matthias did a fantastic job with his team to make the heuristic that will avoid reading the pack files over and over again. And JGit as a caching of pack files that can be configurable. However, the loose refs are a big problem. They are super slow on NFS. And this is because whenever you list directories, you are back with the same problem that we saw before. And what are the problems with pack files? So the ideal scenario is that you want a single pack files, but the reality is that you never get a single pack file, because the moment that you do a GC to have a single pack file, then people start pushing again. And if you have a mono-repo, what are the chances that someone will push into your repo? If you got 500 developers, if they push at least, let's say, 10 times a day, you will have at least 5,000 pushes every day. So it means that if you do a GC every day, at the end of the day, you end up with 5,000 pack files. So you will need to start doing GC and repack all the times. And that doesn't help even do it, let's say, every single minute, because as soon as you finish one, you got another push going forward, and then you just created another one. And what is the problem with the large number of objects? Okay, so let's do a small digression with the git clone. So the git clone is actually organized in different phases. So in the first phase, basically you ask the server how many objects you have got, and we'll give you all the objects and the rest pointing to them. And then the server, the client is telling the server, okay, I would like those refs and those objects. And the server tries to find what is the best representation for those objects to send it to you. However, let's focus on the search for reuse, search for sizes. This one has a complexity that is absolutely a killer. So think about if you got 10 million objects and 100 pack files, and this is not a repo in a bad shape. I've seen repos in a much worse shape. Then, whenever you do a clone, you will need to do 1 billion of scans. And that does not just take time, but eat up a lot of CPU on your side, on the server side. Because remember that JGit, yes, caches the pack file, but caches in compressed format. So whenever it needs to then locate the objects in uncompressed format, needs to be uncompressing in memory. Compressing and uncompressing memory is really CPU intensive. Another poll, let's see what are your problems with mono-repos, so we can then talk about solutions. Okay, so the first solution actually is not being discovered or designed by us in GerritForge, but has been designed by Google many, many years ago. It was originally started by Sean and then was completed, and thanks Hanwen for that, and brought to the open source in JGit by Hanwen from Google. And Hanwen is working very hard to put all the same support in native Git as well. So reftable has been available in theory from JGit 5.6. And let me explain what is reftable. Reftable is a completely different storage format for refs that is specifically designed for repositories that have a lot of refs. So is a kind of clever solution that is using the same concept that Git uses for optimizing its storage, but for the ref itself. So the documentation has been already merged into Git upstream, so you can look into the git.scm.com documentation, and it is fully available end-to-end from 3.4 and 3.5, so you will be able to use it. One warning, so if you convert your repo to reftable, to use reftable, that means that your repo will be visible by JGit, will not be yet be visible in terms of ref by cgit, by the native Git. But of course, you can use a JGit command line to still analyze the repo. And also, one common thing that you can do, you can actually have two copies of the repo. You can also have one repo where the storage is not reftable. The reftable can be enabled and disabled on a repo basis. So you can enable reftable maybe on a repo that is quite big, and you still have a copy of that repo without reftable. They use it for, let's say, backup reasons and so on. A second solution is refs caching that Matthiasson is working on. So the change is still open, but it's looking really good. And if you look at the same numbers that I showed before and the performances that you see with the cache refs, the improvements are mind-blowing. So if you see the 2.1 million microsecond to do a ref lookup on Chromium, that is reduced on 1 microsecond. So on ref lookup can be up to 1 million times faster. And with regards to get refs by prefix, it's still, let's say, not 1 million times faster, but at least 1,000 times faster for the worst case scenario. And that is really, really promising, because it means that once these change will be merged and using Gerrit, then Gerrit will be able to benefit from that as well. With regards to the large number of refs, also, if you want to make your replication faster and your CI/CD faster, then there is a lib module that has been actually available since 2016. It's called refs filtering. It is basically mimicking the same hide refs config settings in Git, but making it more tailored to Gerrit. So basically, if you install the refs filtering that I developed a few years ago, you can actually say that some of the users will get a filtered view of the refs. So even if in reality your repo still has millions of refs, But for your CI/CD builds that actually don't need, for instance, to see abandoned changes or don't need to see the changes that have been, let's say, older than, I don't know, 6 months or something, or maybe they don't care about the meta refs, they won't see them at all. Was a clever way to use the permission backend in Gerrit, and this is basically configured as a super duper fast ACLs. You could achieve something similar with Gerrit ACLs, with the difference that they will be a lot slower, and the price to pay for evaluating the ACLs will not be worth the benefit. But with REST filtering, because the ACL evaluation is super fast, yeah, it's definitely worth it. Just to give you a case study, I cannot mention where the case study was happening, but a repo with 1.5 million refs. So before REST filter implementation, the clone was taking 45 minutes. After the REST filter, it was taking 3 minutes, so 15 times faster. One thing, we needed to enable the caching for change metadata, because the REST filter will filter out basically closed changes. And if you cannot look up the change metadata quickly, of course, it is not going to be fast enough. For the search for reuse, so there is a solution that's been designed by Punch. The solution has been merged, and that is a clever one, because the search for reuse is basically JGit just thinking about what is the best representation for you to send you the objects. But because that calculation may take billions of iterations, at the end of the day, it may take more time than the potential improvement you could have in transferring data. So what Punch has implemented is the concept of deadline for the search for reuse. Very similar to what Edwin implemented for Gerrit. So you define what is your deadline. How much time are you willing to wait for the best representation for an object? And you say pack search for reuse timeout equals 60 seconds. You say, please look for your best match of your blob for 1 minute. But if you can't find it, just send me the one you've got. And we had a specific test case where a 20 minutes search for reuse phase was reduced to just 5 minutes. And that was really good, 4 times improvement. And there are alternatives, of course, because people say, okay, but why don't you shrink the repo by doing some pruning? Yes, if your use case actually allow pruning the repo, is something you may think about it. So some of the customers we have, they have basically two versions of the repo, one with full history and one with pruned history. Pruning means you remove the abandoned changes, or whenever you have when you have a change that has been merged, you remove all the old patch sets, or you just remove all the change metadata altogether. However, there are some situations, and I know for sure that there are some sector in the industry where they've got some strict audit trail requirements where cannot really remove any of the metadata that was bringing a change to be merged or abandoned. So for legal reasons, you may not implement this option. But if you can, that's definitely one of the solutions. It is usually a combination of those problems. Absolutely. So the problems that you may have with mono-repo could not be just one part, but you could be, let's say, in any point in time in a combination of the 3 coordinates. So that means the solution could be a combination of the solution we have been talking about. Please define history rewrite. Okay, so history rewrite, it means that you need to go and edit all the past commits from the origin of time of your repository and rewrite and amend all the commits. And whenever you go to LFS, you have to do that because you basically have to remove all the blobs from your history and they need to be stored into LFS in a way that in your main commits, they're just pointed to a pointer, they are pointing to the blobs. Is there a solution for GC of these mono-repos as well? Yes, of course, you could GC the repos, but the GC in the repos doesn't really help for reducing the number of refs or making them more efficient. Because if you just GC the repo, okay, the repo are more optimized, but you still have a lot of objects. It's not reducing the number of objects. It is not reducing the number of refs. So the GC can only make the organization of packfiles better, but it's not going to solve the problems of the mono-repo.